Hello, and welcome to the Insight.Tech webcast, Attacking Machine Automation for Industrial IoT. I'm Kurt Schwader, your moderator, with today's speakers Christian Eder from Congatec, Edison Shih from Innodisk, and David Nielsen from Supermicro. Christian is Director of Marketing for EMEA and is one of the founders of Congatec. He has 30 years in embedded computing and is committee chairman for the new COM-HPC initiative. Edison Shih is a senior business development manager and has over 10 years of experience in both mechanical and managerial sides of high tech. He possesses a profound knowledge of hardware technology and visualizing trends. With a successful career driving revenue, he continues to discover potentials in sales and specifically focuses on delivering one unified vision of the engineering and market value of products to customers. David Nielsen is an embedded solutions manager with Supermicro. Edison has over 25 years of experience in the electronics manufacturing industry and a 20-year focus on embedded and IoT solutions. First, a little housekeeping. Today's schedule consists of about 50 minutes of presentation, leaving 10 minutes at the end of the hour for audience Q&A. I'd like to run down some features of your viewing console. It consists of a set of windows you can use. I want to direct your attention to the Submit a Question button. This enables you to participate in today's event. You can simply type your question into the box and submit it using the Submit button. That's a really important one because it allows you to ask questions. We encourage you to do so early and often while you're listening to the presentations and the questions fresh in your mind. We'll address as many of these as we can during the closing Q&A. And if you have any questions referring to the eCast operation itself, you can submit those too, and one of our technicians will be happy to respond to you. This webcast is copyrighted and may not be reproduced or used without the express written permission. Our first speaker today is Christian with Congatec. Christian, the floor is yours.
Okay, thank you for the introduction, Kurt. So I want to talk about advantages of hardware consolidations for edge computing here. But let's say before we dive into the details, just to give you an impression, that's myself here. So as you already explained, quite active here in different types of standardization. So that's one of my extra jobs here on top of it. So I can use my engineering background. So I'm not just a marketing guy. And for those which never heard about Congatec, so we're more or less the makers here for computer modules and just board computers. So just to give you an impression about our company. We're founded in Germany, but we're an international company. We're in the US, we're in Asia, we're almost everywhere. So edge versus cloud computing. So of course there's a lot of cloud computing ongoing, but of course this has also some downturns. So edge has much less demand if it comes to connectivity, lower speeds. So it can really utilize local CPU performance here. When it comes to applications like AI, of course, some local processing has big advantages for transactional cost. Of course, the cloud has its unique possibilities, but whenever it comes to bandwidth restrictions or, let's say, short reaction times, the cloud will have its challenges. We see, of course, a lot of competition, let's say, from the application. One is tending toward edge, the other is tending toward cloud. So there will be both sides, of course, in this world. Another big thing what we see, and I will bring those later on together, is hardware consolidation. Of course, the traditional approach of system is having, let's say, multiple different systems, especially when it comes to different or totally different applications. Like here, my examples, it's a PLC application for a motion control, which requires a real-time operating system. Second is a gateway application where typically, let's say, a Linux firewall, things like this are installed. And of course, it's a strong demand nowadays to add some vision or AI controls. Those are sometimes on Linux, sometimes on Linux or Windows, whatever. You bring those together, connect it by a network switch, and link it up to a cloud or to different applications. That's the traditional way. Of course, a lot of boxes. Yeah, you can bring these things together with up-to-date technologies. This is what we understand about hardware consolidation. Not just install multiple programs on a Windows computer. So it's really to consolidate totally different type of applications into a multi-core platform. Come to this later in detail a little bit more. What's the advantages here of hardware consolidation? Of course, less boxes or less systems, less cost. For hardware consolidated systems, you need a multi-core, but this is a multi-core processor, but this is standard nowadays. Of course, maintenance, it's easier, it's less systems, so less things which can fail, and easier to repair because it's just one type of system, not 3 or 5 different ones. It's of course more reliable. You have less cables, and the hardware or the whole system itself is much, let's say, easier. It's less complex, at least from the mechanical point of view. Security, also a big issue. Everything which is connected must be secure. And if you have, let's say, extra box for a gateway or for a firewall or things like that, during maintenance, during installation, and just to check out if what's wrong, is it this box, is it the other one, someone might just pass by connect cables differently and pass by the firewall. This cannot happen with a hardware consolidated system because all of this is in one box. And of course, it's scalable. If you want to add later on extra functionalities, we see this quite often that existing systems must be enhanced by connectivity, security, by AI or vision control. That's scalable even on the same platform. So we see a lot of advantages. But let's talk about latency. Again, it's a comparison, edge computing or cloud computing. What's a demanding real-time application with low latency? A very popular example is on the right hand is autonomous driving. So if you have a weak connection, the car, of course, still has to react fast, which means you need to have a local processing unit here to do all of this. Even it's connected and transmitted once in a while, so the latency can only be down if you have the, let's say, important processing locally. So when it's on a cloud and you have to transmit it each and every time first to the cloud, then do the processing, load it down again, and then react it, this is a big limitation for quite a few applications. Some are quite happy with it, but whenever it comes to whatever kind of motion control industry or, let's say, fast user interfaces, there's no way to just on a cloud solution, edge solution, unless you have a really, really fast and really, really stable network, which is the case in some locations, but not everywhere. At least not in Germany over here. Coming here to a nice combination of things, actually. That's a perfect example for a connected hardware consolidated system. You see here on the top left side real-time Linux running on one of the CPU cores only. The rest is completely isolated. This real-time application runs, for example, a motion control here like a pendulum. Or it can run a robot engine or whatnot. Then, of course, this application needs to be connected here somehow to the cloud for remote administration. So that's the lower left corner, another single core where Linux or any other Edge OS is installed, which provides a secure connectivity to the cloud. This box can be the complete gateway or can just be the firewall, whatever. And on the right side, here you see we reserved the rest of the cores. It's 4 cores just being dedicated for a vision control system. This application utilizes a camera, which then analyzes face detection. All of this is running on a let's say, desktop Linux here in this case, on Ubuntu. And it's even hardware accelerated by an FPGA card, which is introduced to the card. With this thing. We can run up to 300 or even more face recognitions a second here. All of this based on a regular, let's say, 6-core Intel Xeon or Intel i7 CPU. Quite impressive. Typical requirements, what we see quite often, that vision application, AI applications, and IoT need to be added to existing applications. So this makes sense, no matter whether it's at the edge or at, let's say, at a local installation, to bring those together here with a hypervised solution with virtualization support here. So we utilizing the real-time hypervisor coming from a company called Real-Time Systems. So Convatec acquired this company last year. So here on the graphic you see that it's really separating the system. Not just the cores, which are kind of partitions to different applications. It's even the resources like the interfaces, the PCI Express lanes, whatever. All the hardware is kind of sliced up, and one part or one operating system does not even see the other operating systems or the resources which are dedicated to. This allows for really complete isolation. Allows for multiple systems to be installed, and the limitation is just the amount of cores. The beauty of this thing is there's no extra layer in between which takes up resources. This is completely separated, and this adds no latency here to any of the applications. Everything runs at full speed. This, of course, opens endless possibility to combine. These are some typical applications here from an industrial environment, where the hypervisor splits it up to an HMI and a real-time controller, or a gateway real-time controller and another real-time controller, or you have a user interface, or you have a vision control, whatnot. So you're not limited with the operating system, and you're also not limited here what you can do with a hypervised system. Showing an example here of a nice edge computing device here, connected. How to implement it by hardware. Those are examples which have been done utilizing our reliable hardware here. The custom solution created by Permind here to do smart energy or smart energy control here at the edge. We know that the big challenge, of course, to control the electricity here for totally all types of different applications. We have the right energy amount at the right time and space. So this is helping with logic here to control it. This is a, let's say, server performance. It's a Xeon-based processor here, which is not located in a data center, which is located somewhere at the edge at high performance things. And these applications are really growing day by day, and more applications are brought here to the edge, which of course is a big advantage here for the hypervisor to add extra applications without having to take care about the already installed ones. That's just a nice example of a 5x5 measuring board, so that's really tiny, really small. This is a complete server. Here you see the carrier board on the base where 4 10 gigabit Ethernet lines here are installed. Then the small PCB which is on top is a COM Express module which has a complete computing power, and this orange or golden block here which is on top is an enhanced cooling solution, because high performance computing also needs cooling. Just a quick overview on the products. We call this server on modules, so because those are really high performance computers, so we have a wide range of products, not just from our side. So COM Express is an international standard where, let's say, 30-40 different companies provide compute modules with the exact size, the exact same pinout, which are exchangeable. Our offering ranges really here from a 16-core Atom, you see here on the right side, to the Intel Xeon D family, up to also 16 cores, but even higher computing performance here on the width of the slide, and even the latest AMD EPYC-based, the embedded 3000 processors, which are today the fastest you can get here on this small and tiny form factor. Size, by the way, is just 95 times 125 millimeters. So that's really tiny. But of course, if performance requirements are rising, so we're just about, as Kurt mentioned in the introduction, so I'm chairman here for a new standard here, it's called COM-HPC. This is a standard being created within PIC-MG, within the consortium. This is heading towards really, really big challenges here in the future. Performance is growing. COM Express is limited to PCI Express Gen 3 and a maximum of 32 PCI Express lanes. So with this new standard, we selected a new connector with more pins, so we have space for up to 64 PCI Express lanes. And the speed will improve up to generation 5 of PCI Express, which is 32 gigabits per second. Comparison of today's 8 gigabits per second, that's a tremendous amount of performance you get through this connector. About 10 times the performance of the server on modules we can get today. This is actually just cooking if someone's, let's say, deeply interested in it. So the committee is still open to accept members, of course, to create this absolutely forward-looking standard. And let's say Congatec is really, its heart is this open standards, this modular concepts to enable customized solutions. So we believe that edge computing, there's not the edge computer, there's always a lot of special requirements for rugged and solid hardware. I believe we're the right partner to talk to. So with this quick overview, and I hope you get some questions for me later on, I will hand back to Kurt.
Thanks, Christian. Yes, I want to also tell the audience, keep asking those questions. You can ask the questions in the text box and hit submit. Also want to call your attention to a download slides button. You can download the prints and print the slides if you'd like a hard copy. Next speaker up is Edison. Edison.
Thank you, Kurt. Hello, my name is Edison, business development here at Innodisk. In today's agenda, I will be focusing on leveraging industrial hardware solutions for machine automation. Now, let's get right to it. So first, we'll be discussing what is machine automation and its various applications, then to realize some of the challenges for a specific application, that is factory automation. And then lastly, to go over some use cases and Innodisk solutions cater towards those challenges. So what is machine automation? In plain, simple words, it's automated machines, self-driven, self-dependent machines operating day-to-day human tasks with no human errors. So what are some of the advantages for machine automation? Why? There's efficiency in production time. Having a machine that is automated definitely speeds up the production time since no thinking is needed by the machine. There's better repairability and less human errors. Increased accuracy and repairability. When an automated machine is programmed to perform a task over and over again, the accuracy and repeatability compared to an employee is far greater. Less human errors and less labor costs, and increase of safety, less worker comp, and higher volume for production. So different applications from machine automation. One of the hottest topics right now, autonomous vehicles. It's the same idea, enabling driverless cars, automating the vehicle to provision, collect, and manage real-time data, and make decisions from the collected data, and for different applications, surveillance, 24/7 service of non-stop security, as well as provisioning of visual data, automating or enabling the camera to collect information captured, to make decisions, to notify any suspicion or grant access. And then there's warehouse logistics. There's warehouse robots collecting data from a host server, determining which products to ship, pick them up, and package and delivery. And last but not least, factory automation, which is our head topic today. From beginning to end, train robotic arms to build different products based on data, quality control cameras with automated optical inspection of product for mass produced, to package and finish goods and then send out with delivery. Today we'll be focusing on the factory machine automation, its challenges and possible solutions. So factory automation, some challenges, reliability and stability, management, environmental challenges, and security. Here is a great example of a automated factory or Industry 4.0. First, on the left side, there is a product design. When the design is, footprint data is sent to Molly to make engineering prototypes. And then the prototypes are then sent to automated production lines based off prototype design, which could be using optical capturing of the prototype models. And then mass-produced products are packaged for delivery and tracking, which are also automated. And finally, sent to mass distribution from either retail stores or e-stores, which can also be automated and unmanned. So what are some key challenges to a smart factory? First of all, there is reliability and stability. On the factory floor, there might be data protections, challenges under abnormal power supply, management challenges. It has to support 24/7 service operation and maintenance requirements. Environmental challenges has to tackle against harsh environment conditions, and data security challenges to protect the system from being attacked. So reliability and stability. An unstable power supply is a huge risk factor for any device using flash memory. Algorithms for safe shutdown has been available for a long time, but not many are aware of the preventative measures available to ensure a safe power on and power off, as well as a more stable performance. This is huge for factory automation. Production sites are to be always on for 24/7 to increase production and efficiency. You'd want to make sure that there's no data loss even under certain unstable power conditions. That is why Innodisk has end-to-end power production solutions catered toward different power conditions. There's the iCell, advanced data protection that provides backup power during power failures and ensure data in buffer stores to NAND flash. There's iData card, comprised of built-in low power detector and firmware power down recovery algorithm that prevents ECC failures from occurring as a result of the data inconsistencies due to loss of power. And there's IE power card, sophisticated technology that safeguards your SSD where your data is and prevents power instability from affecting the whole system. On to the next challenge. Management. Machine automation means that we're moving into a future with fewer human operators and exponentially growing numbers of interconnected devices. Monitoring the health and managing end devices with no physical access becomes one of the key challenges to enabling a smart factory. Innodisk has just a solution catered to manage the status of multiple devices simultaneously. There is an iCAP, a remote device management platform that could be accessed through public or private cloud. iSmart to interact with iCAP and provide preventative equipment lifespan to reduce potential downtime, and easily swappable storage solutions for effective maintenance. Next, discuss challenge with the environmental challenges. One of the key factors in building a smart factory is to ensure and improve manufacturing productivity. Instead of focusing on the performance of people, extra attention should be brought to the efficiency and ruggedness of computer components. So some examples for possible environmental threats would be sulfur contamination in a factory floor, extreme heat and changing conditions such as vibrations, acid, dust, and other harmful materials. So realizing those potential threats, Innodisk has anti-sulfuration materials on all of the DRAM modules, DR4 DRAM modules, and side fills on the ICs to withstand vibrations. In case there's a vibration, we don't want any data or components from the solution to fall off. Wide temperature solutions for extreme heat or extremely cold conditions, and conformal coating for anti-dust and other harmful materials that might eventually get onto the component. Going on next to the data security challenge. Security for edge computing is often an afterthought, even though the consequences are worse than neglecting security in cloud. Considering the automated optical inspection system in the factory floor, what if someone hacked into the system device and generate erroneous data that could cause the AOI system to fail detection of a flaw or a defective product? This might eventually cause a huge impact on a brand, mass distributing defective products throughout the source. Such isolated devices are often a great target because there is separation from core systems, where you might have ways to detect attacks. Which is why enabling write protect for extra security prevention from data altering becomes such a key feature for our data storage devices. And this AES encrypted solutions put an extra layer of security to edge computers. Next, I want to jump on to the industrial solutions and some successful cases that we have. Here is a use case for efficient packaging. This customer is utilizing Innodisk's compact form factor, so then with wide temperature and high endurance SLC cards. Mass packaging is essential to ensure integrity during transportation and safe consumption of food items. The machinery involved in these processes needs to be efficiently churned out products on an around-the-clock basis and have an extremely low tolerance for downtime. Being designed to last 5 to 10 years means that only the most enduring components are acceptable. Facing these challenges, an experienced manufacturer of food packaging equipment of our customer is approached Innodisk for a memory and storage solution for a module-based device. The device will pack at a rate up to 300 items per minute, and keeping downtime to a bare minimum was the #1 priority. Due to module restrictions, the client is also need a solution to solve compatibility issues with the flashcards. The result? The manufacturer found both the needed endurance and customizable solution through Innodisk expertise. With this design in place, the module and the components could deliver lasting performance and could be easily swapped if necessary to keep downtime to a minimum. Common challenges to migrate to a smart factory would be 24/7 operations, always-on mentality, module-based components to ease of integration, customizable for different space constraints. And our solutions, high endurance, long-lasting industrial solutions to ensure reliable performance, easy fit components, small form factors with various capacities, crossover extensions to make components compatible with existing platforms with little or no effort in design customization. Here are some examples of our solutions. Flash modules in any form factor, made with the highest quality of flash to ensure high endurance as well as specialized firmwares for power protection, as discussed for one of the challenges for factory automation. DRAM modules in any form factor, wide temperature, anti-sulfuration to protect the edge computer from harsh environmental challenges. IPA or industrial peripheral add-on cards, wide temperature, add-on connected device for any future expansions as well as compatibility and connectivity. And ICAP software for out-of-band remote management for the ease of management challenges. Thank you. And that's all I have for today. Back to you, Kurt.
Great. Thanks, Edison. A lot of information there in terms of factory automation factors and use cases. David, you're up next.
Thank you. So good morning and good afternoon, everybody. So very quickly to the agenda for my session, I will cover fanless computing devices with some applications, as well as a couple of other disruptive technologies for the industrial space, specifically AI and 5G. First up, the fanless. So utilizing some low-power Intel Atom platforms, Supermicro has developed a successful fanless gateway platform for manufacturing environments. Along with the fanless feature, wide operating temperature is another key element that helps monitor the manufacturing environment. The application we're showing here utilizes some interfaces such as RS-232, which allows manufacturers to maintain their existing devices in their legacy applications. At the same time, we enable multiple network and USB interfaces that allow for the device to capture data such as video or for monitoring quality as well as user input, while still having the performance headroom to drive multiple displays. Okay, so another successful industrial application we have for the Atom fanless devices, in this case our IP51 rated E50 system, which allows fuel suppliers to monitor tank levels, and they watch the pump activities to help enhance their delivery services. So, and of course, it's not just the Atom processor that finds service in the fanless applications. Some of our industrial customers' applications require greater performance, so we offer the i3, i5, i7 solutions as well. And specifically for the industrial market, we have a device that offers a wider voltage input, as well as DIN rail mounting and additional I/O expansion capabilities. Okay, Supermicro partners with Intel and Zedata to provide an RFP kit that offers an out-of-the-box gateway management solution. So devices come provisioned for install, eliminating the need for technical expertise at the install location. So this particular RFP kit provides a secure means to deploy and remotely manage gateway devices in all types of environments. So next up, we'll look at how we bring AI to the edge. Okay, so while deep learning is still primarily a data center operation, increasingly we're supporting analytics at the edge, where the data is being collected and aggregated. So this offers benefits of reduced latency and prescribing necessary actions at the edge, as well as putting inferencing into action. So according to industry research, we can expect the trend of AI-capable devices at the edge to increase by 15 times by 2023. So this translates to a 7-fold increase in the ratio of AI applications at the edge compared to those in the data center. So where we once saw only about 6% of AI activity at the edge, now we can expect that to increase over the next 5 years to around 40%. So in keeping with this trend, we're seeing the demand for smaller one-use systems with a multitude of network connections and expansion capabilities. So along with the increase in compute capacity at the edge, we're also seeing some additional storage requirements. A couple of examples of systems that fit the requirements for AI-capable devices are pictured here. One is our 5019D-FN8TP, powered by the latest Intel Xeon D platform. It supports a single GPU, and this system has been successfully deployed in inferencing applications at the edge. So for applications requiring a greater level of connectivity, as well as support for multiple expansion cards, we have the 1019D. It offers 13 network interfaces, hot swap drives, two 16-lane PCI Express 3.0 sockets, as well as multiple M.2 interfaces for storage and wireless connectivity. So based on that, the concept of connectivity, so more connectivity means more edge devices, and consumers are looking for solutions that are tested and optimized for particular use cases. In this case, Supermicro has partnered with Intel to provide a select solution for the universal customer premise equipment. So customers can confidently select a hardware solution that will reduce their time, effort, and expense, bringing solutions to market. So another disruptive technology that will impact many edge applications is 5G. So addressing the why of 5G, it really breaks down to a few key factors, right? Faster speed, lower latency, stability, and better coverage. We expect this technology to drive new opportunities and create new use cases for wireless at the edge in all markets. So one of the products we have that are addressing the demand is the flexible multipurpose 1019D FRN5TP. So what we've done here is designed a system that is capable of delivering changeable front I/O expansion, whether that's used for adding a significant level of connectivity at various speeds. It could be GPU capability or additional storage or a mix of those features. So here again, we employ the power of the Xeon D, which we offer in all performance levels to meet customer-specific application requirements. Okay, so I touched on the 1019D FHN13P system earlier, but as it relates to multiple application scenarios, I wanted to point out a few specific features here. So based on the powerful Intel Xeon D 2100 series, we offer this system in a variety of core counts, from 4 up to 16 cores. So also the removable expansion card cage allows for simplified assembly of the system. Our thermal design allows for us to run this system in 0 to 45 degree operating temperature, which is much higher than your typical data center systems. So both AI and 5G applications, share some common requirements from a base hardware perspective. So high performance, scalable solutions, and small form factors, lots of connectivity and expansion options will meet the needs for both of these areas. So in this use case, we worked with a service provider to deliver a unit as an intelligent roadside unit to manage V2X communications. So it serves as the MEC, which is sometimes referred to as the multi-access edge computing, or otherwise sometimes known as a mobile edge compute device. So it collects data from the multiple sources and communicating to those devices as well as the central offices in the cloud. To achieve this, we came up with an IP65 enclosure that allows us to deploy this device in a -40 to +55 degree C environment. So for a closer look at this system, it's the E403. We offer this in a variety of core counts as well, and also up to 3 PCIe Express lanes to accommodate a range of add-on features. So to recap our approach to industrial automation, we typically see the following requirements driving the opportunities for the smart factory. Gateways that are fanless and low power, offering a wide range of performance levels with graphics capability. And at the edge, we see 1U and wall mount front I/O designs with expansion capability and a high level of connectivity. So Supermicro offers the most extensive portfolio of performance computing products with hundreds of designs from chassis to motherboards, power supplies, add-on cards, and modules. We also provide global on-site services and open server management software, all from our global headquarters in the heart of Silicon Valley. So thank you for your time. Back to you, Kurt, for the Q&A session.
Great. Thanks, David. We are now to the Q&A. I want to remind the audience you can keep submitting questions even through the Q&A. We encourage you to do so. Take advantage of the expertise we have here. Let's start with a question for Christian. There's a question about how does COM HPC relate to the principles of ETSI MEC? Looks like ETSI MEC is a multi-edge computing spec.
Yeah, thank you for this question. So this is, of course, a telecom spec, or let's say telecoms-related spec here, which allows, let's say, to program applications with low latency and high bandwidth. Of course, both things speak here to the platforms I described. I think that's a good fit here for the current COM Express, that this could be the right platform to run this MEC applications. It could also be, of course, an even better platform in the future for COM HPC, because this is really heading towards a much higher I/O throughput, so it's a lot of communication which has to happen in here. So I'm pretty sure this will become one of the preferred platforms, at least I hope so, for these types of applications.
Okay. Edison, there's a question about industrial grade. Can you talk a little bit about how industrial grade it might be different from enterprise grade?
Right. Let me pass this on to Eddie, which is the product manager for our industrial solutions. Eddie?
Yeah.
Hello? I'm not sure if Eddie is connected.
You can't hear? Let me, yeah.
Hello, can you guys hear me now? Sorry.
Yes.
I believe there's a technical difficulty. So there's a misconception in different grades of flash, where everyone believes that all the flash could be used for any applications and whatnot. But as an Innodisk company, we realize that industrial grade for different applications such as military or embedded, or also for ruggedness of the environment, such as harsh deserts or wide mountain ranges. Those are very important. Comparing to enterprise server systems where you pretty much assign flash storage devices and use and forget kind of thing. But for environmental hard to reach places and harsh deployments, industrial grade becomes very critical for mission critical customers that has to work for a long period of time, and then requires a more extensive use of the flash storage devices.
Oh, yeah. Okay, great. David, in terms of the IoT Gateway RFP kit you mentioned, there's a question about what do they do? What's inside of it? What do they get? And maybe any sort of pointers on how to start with it.
Okay. Yeah. So that's our E50 fanless system. What typically comes with it, you have options in regards to your storage and your memory depending on your application. But it also, as part of an RFP or a solution-ready kit, it comes with software pre-installed, and that's available on a subscription basis for 1, 2, 3 years. That's through our partners, Data. So again, it can be configured, based on very specific application needs, but it really is a ready-to-go kit with everything that's necessary to deploy and launch and begin managing that device remotely.
Okay. And does it come with software, OSs, those kinds of things, drivers?
Yes, it's ready to go. Everything's installed.
Okay, great. Thanks, David. Let's see here. For Christian, when will COM HPC become available?
Yeah, as mentioned, so this is cooking here and the standardization here. So we're doing a good job, but it always takes a while before a spec can get released. So I assume that the specification will be released later this year, so towards the end of the year. And I expect first products to show up, let's say, maybe 1 year from now, something like that. It's still a mile to go, and as mentioned before, it's still possible to influence it. So if you feel that that's a strong demand for you, of course, be invited to join PicMake and to join this work group.
Okay, so the standard's pretty targeted at industrial IoT then, and if you have interest in that and shaping some of the things to tune for your application, definitely sounds like it's worth participating.
It's much more server related actually. So ComExpress was purely, let's say, industrial related. So it's still industry related, but also opens some like edge servers. So that's quite typical. It's, let's say, industrial requirements because it's outdoor, it's kind of rugged, and it must be as fast as a server. So we have big challenges to solve.
Okay. Okay, great. Let's see here. One for Innodisk. So what are some common mistakes to avoid when you're doing edge computing applications?
Right. Thank you, Kurt. So this is my opinion as well. So there are some edge mistakes. Number one, doing too much at the edge. So the rule of thumb is to keep it small, cheap, and easy to replicate. The edge device should be purposely built and only do the minimum of what's needed to collect, process, and transmit data. All those data going through, it's going to be hectic, and there's latency issues as well as deployment issues if you're doing too much at the edge. Simply put it. The mistake number two is to neglecting security at the edge, which I also talked about during our slideshow, that security at the edge is often attacked, very easy to target because you're not easily to prevent and find out who is actually attacking you at the moment. So those are the two challenges that people are facing and things that you want to avoid if you want to deploy edge computing devices. Okay.
So I guess in terms of if you can answer, maybe if you ask yourself the question of this is kind of a somewhat hard real-time requirement to get some information processed and returned to the device, maybe that points to needing to be at the edge. But if you find yourself doing fancy things at the edge, maybe that's better to push back into the cloud. Is that kind of
correct?
Rule of thumb?
Right.
Okay.
Definitely.
And then I guess, you touched on a great security point, and maybe we can bring David and Christian in for these comments on security as well. Christian, what about security? Are there things in these platforms or the hardware that you're doing that can enhance security and authentication and encryption kinds of things?
Of course, there are, let's say, onboard TPMs, things like that, to safely store keys. There are also possibilities if you want to roll out, let's say, thousands of units, how to identify them correctly to have let's say, a secure device rollout, things like this. There are mechanisms in place. Although even down to the, let's say, booting the operating systems and whatnot, having all these functionalities, of course, to see if something was manipulated, if there was some attacks. So this developed quite a lot. And even, let's say, some weaknesses sometimes, even in the BIOS or UEFI to this level, there are, of course, also patches required here over time. So what we do is we of course, close those known security gaps with BIOS or UEFI updates. I think this should be natural nowadays, of course, to keep systems, especially when they're connected. It's not just for edge devices. Each device which is connected has to keep high security levels.
Right.
That's a task over time. It's not a one-time effort. You have to maintain it over time.
Right. And in terms of HPC, do they do anything with respect to addressing security or add any kinds of requirements there? Or?
It's the same procedures actually. It's not nothing different so far, at least, but it's still in an early stage of discussion actually. Right now, of course, those procedures, those mechanisms and procedures we had before will be implemented, of course, but it's not that much part of the standards. It's then part of the implementation of the single vendors.
Okay. And David, in terms of Supermicro and security features in these devices that you were showing?
Yeah. So in regards to, I think as Christian mentioned, TPM is a very important place to start from a hardware perspective. All of the small form factor devices, all of our fanless devices have a TPM chip down on the board, so no need to add additional modules. When you get into the larger systems, typically we'll offer a header there to give you a little bit more flexibility about which module you want to add. And that's a great place to start. And speaking purely from the hardware perspective, when it gets into software, obviously there's a lot more you can do. And also, as Christian mentioned, keeping up with the BIOS patches. I mean, those come out. Occasionally we have to revise the BIOS to make sure that we're still secure.
Okay. Let's see, a question for Innodisk. Can you elaborate on Innodisk's solutions on tackling environmental obstacles? You mentioned a lot of things relating to dust, industrial environments, temperature, those kinds of things. What kind of considerations and what kind of solutions do you have for those kinds of environments?
Yeah, so for different kinds of environments, we do have a proprietary solutions for it. So
you're sounding a little bit far away. Can you?
Hello?
Yeah, come a little bit closer. There you go. Yeah,
okay. Sorry about that. Yeah, I'll talk a little louder. Sorry about the audience. But we're talking about deployment in high extreme temperatures and also in deserts, also in high mountain ranges. So we do have a performance upgrade like a conformal coating, anti-sulfification, and then we also have different types of sizes to support these extreme environmental obstacles. That fits in line for industrial different usages, as you can see in maybe using submarines, deep water pressures, and also used in tanks, military environments, and also in even automations, as we know it, in harsh environments of production assembly.
Okay, great. Thanks. Christian, you mentioned something about the latency and how it's not adding any latency in terms of the real-time hypervisor that's being incorporated. Can you elaborate on that? And maybe you can also talk about resource sharing. Does the hypervisor allow different VMs to do resource sharing and partitioning, that kind of thing?
First of all, the hypervisor, let's say, adds no extra latency. Sorry for that. Which means so it's really separating it. It's putting up the different operating system, and then it's out of the game. So sharing devices is possible, but then you need, let's say, one extra instance which takes care about this sharing. So It's quite typical for real time that you just assign devices to one or the other. Of course, to have shared spaces, you can configure shared memories, for example, to exchange data. You can exchange data by virtual Ethernet ports, and installing, let's say, a host system on one of the cores. You can even, let's say, share hard drives or memory storage or things like that. But this needs an extra instance because the real-time hypervisor has no layer in between. It's totally out of the game.
Right. Okay.
At the end, it just separates it, and that's why this does not add any latency here to the applications. It's not interpreted, so it's really just separating it. It's like slicing up your computer.
Right. Okay. Great. David, you mentioned a Supermicro application example of the fanless device in the gas station. Is this device installed outside? And in terms of what were some of the challenges associated with that installation? What kind of environmental factors played a role in making it more complicated to deploy and operate?
Okay. Yeah, so it was that particular device is IP51 rated. And interestingly, it's the same device as we offer on our RFP kit that we discussed earlier. So in this particular case, this device it's not installed outside in the environment. It's only IP51 rated, so it's not capable of dealing with the rain and the extreme conditions. It is a wide temperature device. It goes from -20 to 50 degrees C. So it is capable of installing in locations that are sheltered from the elements, but still exposed to damp, dust, and cold. So it's in that regard, it can be installed in a non-controlled environment, just not in open exposure to the elements.
Okay, great. Eddie, or Innodisk, Edison, Eddie, let's see. Why is it pivotal to employ SLC in machine automation? What's the uniqueness about it in these applications? Maybe you can also introduce the audience to the SLC as well.
Okay, so mainly, as we all know, for Flash.
And you're a little bit still far away. If you can
hello.
come closer.
Okay, yeah. Okay, so can you hear me now? Sorry about that.
Yep, just stretch. Keep the volume.
I'll talk a little bit louder. But anyways, for SOC and MLC, we know different layer cells. And then why SOC is more important, as I talked about it before, where industrial side, there's a lot of different deployments in different regions. And one of the main reasons is for servers involved. If you deploy machines or deploy any modules in hard-to-reach places, SoC will actually have higher endurance, higher P cycles, comparing to MLC and maybe 3D TLC product lines on the market where there's actually more reliability. We're talking about around a lot more comparing to the MLC product line. And then when we talk about 3D TLC that's in the market right now, we see that there's a lot of use in the consumer side, looking at around 1.1K to 1.5K in the PE cycles. But for industrial and Innodisk, when we pride ourselves in industrial usages, we're looking at endurances of PE cycles at 3K PE cycles. We want to make sure our customers and all the ones that's using out there with mission critical devices, making sure that they'll actually last a lot longer comparing to what you see in the market in the consumer side right
now. Okay. Christian, in terms of the processes you're deploying, I mean, they're fast and they get hot. So what's the strategy for cooling?
That the concept of the computer module also gets along with a cooling concept in parallel. I think I had one in my slide here. Let me push this one out. So what you see here is this orange block here is a heat pipe based cooling. So with this enhanced cooling, we managed to bring down the CPU temperature compared to, let's say, traditional way, about 15 degrees centigrade. Taking into account if you reduce the temperature by 5 centigrade, this might double the lifetime of your system. So this is really a big help for long time installations, of course, rugged installations, extended temp installations. And it also boosts performance. As we know, the cooler the processor, the more you can overclock it with this turbo boost functionalities, you get more performance, and it's more reliable. So at the end, it's just a simple piece of mechanics, but if this is highly optimized, so you can really bring more out of your system, actually, more lifetime, and you can save cost.
Is that just a heat sink, or is a heat pipe different?
This is not a complete heat sink. In this case, it's a mixture. What we see usually is it's coming with a heat spreader, which is much more flat than this one you see here.
Okay.
This conducts here to a system housing, to your system cooling at the end. Typically, it's conducted to your metal chassis. Things like that.
I see. So it just helps direct.
Of course, there are different versions with installed fans and whatnot, and this has really that's a mixture. So it has a let's say it is a cooling block already, but it is a flat surface which you install then to your housing, because this is intended here for about 50-60 watt of power consumption. And to cool this in a passive way is challenging, but it's possible.
Okay, great. I guess that pretty much ends our top of the hour here. We've got no more questions from the audience. Appreciate Christian, Edison, David for sharing all of your insights, and Eddie for the Q&A. Appreciate that. Lots of great insights on machine automation for industrial IoT. Want to thank you, the audience, for attending today and contributing excellent questions remotely. Again, a reminder that this webcast is copyrighted and may not be reproduced or used without express written permission. Thanks for attending. Have a great day.